Good evening, and welcome to The Sleepy Dreamer. Tonight, as the world outside grows quiet and the stars begin their silent vigil overhead, I invite you to settle in, take a deep breath, and let your mind drift towards something extraordinary. Something hidden. Something that holds everything together, yet never shows its face. We're going to explore the universe's greatest secret. Not with urgency or noise, but slowly, gently, the way a secret should be told. Because this evening's journey isn't about what we can see. It's about what we cannot. Before we begin, I'd love to know, where in the world are you listening from tonight? Whether you're beneath city lights or countryside darkness, under a ceiling or under the stars themselves, it's a genuine pleasure to have you here. And if you're new to these cosmic lullabies, please take a moment to like this journey and subscribe. It helps these quiet explorations reach other curious dreamers like you. To those of you who've already joined our little constellation of night thinkers, thank you. You're the reason these stories keep unfolding. Now, I do hope this isn't so interesting that it keeps you awake. But if it does, well, at least you'll be lying there quietly, learning that the universe is not quite what it seems. So, as you relax, let's begin with a simple question. A question so fundamental that it changes everything once you truly hear it. What if most of the universe is invisible? Not invisible because it's far away, not invisible because our eyes are weak, but invisible because it simply does not shine, it does not glow, it does not interact with light at all. What if the stars, the galaxies, the glowing nebulae, and every luminous thing you've ever seen or photographed or dreamed about? What if all of that, every bit of it, is nothing more than a thin veil stretched over a vast invisible presence? That's not a thought experiment. That's reality. When astronomers carefully measured the universe, when they added up all the shining matter, the stars, the planets, the glowing gas clouds, every luminous thing, they discovered something astonishing. All of that light, all that brilliance scattered across billions of light years accounts for only about 5% of the total mass and energy in the cosmos. 5%. The rest, the other 95%, it's something else entirely. Something that doesn't emit light, doesn't reflect it, doesn't absorb it. It is profoundly, utterly dark. About 27% of the universe is made of what we call dark matter. It has mass, it has gravity, it holds galaxies together and shapes the largest structures in existence, but it remains completely invisible to every telescope, every camera, every human eye that has ever gazed upward. And the remaining 68%, that's dark energy. An even stranger force that pushes the universe apart, accelerating its expansion in ways we're only beginning to understand. But tonight, we're not here for dark energy. Tonight, we're here for the dark matter, the scaffolding, the invisible architecture, the quiet hand that holds the stars. Let that sink in for a moment. 85% of all the matter in the universe, the actual stuff, the mass that pulls and shapes and gathers, is hidden from view. You can't see it, you can't touch it, but it's there, everywhere. It wraps around galaxies like an invisible halo. It stretches across the cosmos in vast silent webs. It flows through this room, through your body, through the earth itself, without making a sound. It is the universe's greatest presence, and yet it leaves no trace in the light. If you've ever felt small beneath the night sky, If you've ever stood in the darkness and felt something larger than yourself, something unknowable and immense, well, you weren't wrong. You were standing in the presence of something real, something that science has only recently begun to name. For most of human history, we believed that what we saw was all there was. The stars were fixed, the heavens were eternal, light defined reality. But now we know better. Now we know that light is the minority, the exception, the quiet guest at an enormous invisible party. And the darkness is not absence, it's not emptiness, it's structure, it's mass, it's gravity in its purest, quietest form. The ancient philosophers used to say that nature abhors a vacuum, but nature, it turns out, is perfectly comfortable with invisibility. In fact, nature prefers it. For every glowing star, there are halos of dark matter 10 times its mass. For every shining galaxy, there is a web of darkness stretching between it and the next. We live in a universe where the visible is the decoration and the invisible is the foundation. Imagine walking into a grand cathedral. Your eyes are drawn upward to the soaring ceilings, the stained glass, the light streaming through in brilliant colors. But what holds it all up? The scaffolding, the beams, the hidden structure buried in the walls. You don't see it, but without it, the whole thing would collapse. Dark matter is the scaffolding of the cosmos. It holds everything loosely together, gently, invisibly, allowing the light to rest upon it like paint on a canvas. And here's the beautiful part. We didn't go looking for it. We stumbled upon it. Astronomers were simply measuring how galaxies spin, how galaxy clusters move, how light bends around massive objects, and the numbers didn't add up. The visible matter wasn't enough. There had to be something else, something with mass, something with gravity, something dark. At first it seemed impossible. How could the universe be mostly made of something we couldn't see? But the evidence kept piling up again and again from different directions, different methods, different corners of the cosmos. Galaxies rotating too fast, clusters held together by invisible hands, light bending around masses that weren't there. The universe was whispering a secret, and slowly, patiently, we learned to listen. So tonight, as you lie there in the quiet, I want you to imagine something. Close your eyes if you'd like. Picture the darkness around you, not as emptiness, but as presence, not as nothing, but as something, because it is. Right now, as you listen to these words, particles of dark matter are streaming through you, millions of them, perhaps trillions. They pass through your body, through the walls, through the earth itself, barely interacting, like ghosts moving through a world they can't quite touch. You're surrounded by the invisible, held by it, immersed in it, and yet you are safe. Because dark matter is gentle. It doesn't collide, it doesn't burn, it doesn't pull or push in violent ways. It simply exists, quietly influencing, shaping the universe on the largest scales while leaving the small things, like you, like me, untouched. It's the universe's way of holding everything together without squeezing too tight. Before we go any further, before we explore the evidence and the mysteries and the astonishing ways we've learned to detect the undetectable, I want to leave you with a thought, a question to carry with you through the rest of this journey. If darkness holds everything together, then what truly gives the universe its shape, matter, or mystery? Perhaps in the end, they are the same thing. So take a breath, settle in, and let's drift together into the dark, because the story of the universe isn't written in the light, it's written in the silence beneath it. So here we are, drifting together in the quiet, contemplating the invisible. In the last chapter, we learned that most of the universe is dark. Not dark like a room with the lights off, but dark in a deeper way. Dark matter doesn't interact with light at all. It doesn't glow, doesn't reflect, doesn't absorb. It is profoundly, elegantly hidden. But here's the beautiful question that kept astronomers awake at night. If we can't see it, how do we know it's there? How do you prove the existence of something that leaves no fingerprint in the light? The answer is gravity. Gentle, patient, undeniable gravity. You see, dark matter may be invisible to light, but it cannot hide from the one force that connects all things with mass. Gravity doesn't care if something shines. It only cares if something has weight, if something pulls. And dark matter pulls. Oh, does it pull? Over the decades, astronomers discovered not one, not two, but several completely independent ways that this invisible mass reveals itself. Different methods, different telescopes, different corners of the sky, all whispering the same secret. There is something out there, something massive, something dark. Let me take you through them, slowly, one whisper at a time. The first clue came from watching galaxies spin. Imagine a spinning ice skater. When she pulls her arms in close, she spins faster. When she stretches them out, she slows down. That's conservation of angular momentum, and it's one of the most reliable patterns in physics. The same principle applies to planets orbiting a star. Mercury, close to the Sun, zips around quickly. Neptune, far out in the cold dark, drifts lazily along its distant path. So when astronomers began measuring how fast stars orbit around the centers of spiral galaxies, they expected the same pattern. Stars near the glowing galactic core should move quickly. Stars farther out, where the light fades and fewer stars are visible, should slow down, just like Neptune compared to Mercury. But that's not what they found. In the 1970s, astronomer Vera Rubin and her colleagues carefully measured the speeds of stars in spiral galaxies, plotting what we now call rotation curves. They used the Doppler effect, the same principle that makes a siren change pitch as an ambulance passes you, to measure how fast stars were moving toward or away from Earth, and the curves were flat. Astonishingly, stubbornly flat. Stars on the outer edges of galaxies were moving just as fast as stars closer to the center. Some were even moving faster. It didn't make sense. There wasn't enough visible mass out there to hold them in place. By all the rules of gravity, those outer stars should have been flung off into space long ago, like a stone released from a sling. But they weren't. They stayed in their orbits, moving far too quickly for the light we could see. The only explanation? There had to be more mass, a lot more. An invisible halo of matter, 5 to 10 times the mass of all the visible stars combined, wrapped around each galaxy like a gentle, unseen hand, holding everything in place. That invisible mass is what we now call the dark matter halo. It doesn't shine. It doesn't cluster in the bright spiral arms. It spreads out in a vast, diffuse sphere, reaching far beyond where the last stars twinkle and fade. And it holds the galaxy together with nothing but gravity's quiet pull. Imagine wrapping a galaxy in a blanket you cannot see. The stars are the embroidery, the bright threads you notice first. But the fabric itself, the part that gives it structure and weight, is invisible. That's the dark matter halo. The second whisper came from something even more dramatic: gravitational lensing. Einstein taught us that gravity isn't just a force that pulls, it's a bending of space itself. Massive objects like stars or galaxies curve the fabric of space around them, and when light travels through that curved space, its path bends. It's like looking at a streetlight through a glass of water. The light bends as it passes through, distorting what you see. In the cosmos, mass does the same thing to light from distant galaxies. When astronomers pointed their telescopes at massive galaxy clusters, they noticed something extraordinary. The light from galaxies far, far behind those clusters was being stretched and warped, bent into arcs and rings and multiple images. The foreground cluster was acting like a cosmic magnifying glass, a gravitational lens. But here's the twist. When they calculated how much mass was needed to bend light that much, the numbers didn't add up. The visible galaxies in the cluster weren't nearly heavy enough. There had to be something else. Something with mass. Something bending the light but not emitting any of its own. Dark matter. Using gravitational lensing, astronomers could actually map where the dark matter was. They couldn't see it directly, but they could see its effect on the light passing through it, like seeing a handprint in the fog. The dark matter formed massive, invisible scaffolding around and between the galaxy clusters, far more spread out and far heavier than all the glowing galaxies combined. One of the most famous examples is called the Bullet Cluster. Two galaxy clusters collided, passing through each other like ghosts in the night. When they did, the hot gas, which glows in X-rays, slowed down and got left behind in the middle, heated by the violence of the collision. But the dark matter, it didn't slow down at all. It passed right through collisionless, unaffected by the crash. When astronomers used gravitational lensing to map where the mass was, they found it had separated from the glowing gas and continued forward with the galaxies themselves. It was the smoking gun, the ultimate proof. The mass and the light had split apart. The dark matter revealed itself not by glowing, but by pulling, by bending the light of distant galaxies into telltale arcs. The invisible scaffolding had left its mark. The third whisper is perhaps the most profound. It comes from the oldest light in the universe, the cosmic microwave background. About 380,000 years after the Big Bang, the universe cooled enough for light to travel freely for the first time. That light has been traveling ever since, stretched by the expansion of space into microwaves. It fills the entire sky with a faint, uniform glow, a baby picture of the cosmos. But it's not perfectly uniform. There are tiny ripples, temperature variations of only a few millionths of a degree. Those ripples represent tiny differences in density in the early universe. Places that were just a little bit denser, and places that were just a little less so. Here's the key. Those ripples match perfectly with what we'd expect if the early universe was dominated by cold, dark matter. The patterns, the scales, the sizes of those fluctuations all depend on how much dark matter there was, how it clumped, and how it pulled ordinary matter into the denser regions. When scientists analyzed those ripples in exquisite detail using satellites like WMAP and Planck, they could calculate the cosmic recipe: about 27% dark matter, about 5% ordinary matter, the rest dark energy. The cosmic microwave background was like a receipt from the universe's first moments, itemizing exactly what went into the mix. and dark matter was right there, written in the pattern of ancient light. 3 completely independent lines of evidence: galactic rotation curves, gravitational lensing, the cosmic microwave background, each discovered separately, each measured differently, each pointing to the same invisible presence. That's how science builds confidence, not from a single experiment, but from a chorus of different voices all singing the same song. Of course, there are alternatives. Some physicists wondered if maybe, just maybe, we had gravity wrong. Perhaps at the enormous scales of galaxies, Newton's laws and even Einstein's equations needed adjustment. They proposed modified Newtonian dynamics, or MOND, which tweaks the rules of gravity when accelerations are very, very small. And you know what? MOND works surprisingly well for individual galaxies. It can predict their rotation curves just from the visible matter, without invoking dark matter at all. But when you zoom out to galaxy clusters, to the bullet cluster, to the cosmic microwave background, MOND struggles. It can't explain why the mass and the light separated in the bullet cluster. It can't match the precise patterns in the ancient cosmic light. It doesn't fit the full, beautiful picture the way dark matter does. So while MOND remains an intriguing idea, the evidence overwhelmingly favors the existence of dark matter, not because scientists want it to be true, but because the universe keeps insisting that it is. Think of it this way. Dark matter is like wind. You can't see wind, but you can see the leaves rustling, the trees bending, the waves on the water. You can feel it on your skin. You know it's there because of what it does, not because of what it is. Dark matter bends light. It holds galaxies together. It shapes the largest structures in the cosmos. It left its signature in the very first light. We may not be able to see it, but we can see its hand everywhere we look. And so, as you lie there in the quiet dark, think about this. The universe is held together by whispers, not by shouts, not by blazing light, but by the gentle, invisible pull of mass that does not shine. It's a humbling thought, isn't it? That the foundation of everything is something we cannot see. That the scaffolding holding up the cathedral of stars is hidden from view. But isn't that fitting? Isn't that beautiful? Because the most important things are often invisible. Love, thought, memory, gravity, and now, dark matter, the quiet architecture of everything. We've been drifting together through the invisible universe, learning how dark matter reveals itself through whispers of gravity. We've seen how it holds galaxies in its gentle grip, how it bends light around massive clusters, how it left its fingerprint in the oldest light we can see. But tonight, I want to show you something even more profound. Something that will change the way you think about the night sky forever. Because dark matter didn't just passively exist in the early universe. It built something. It wove something. It created the largest structure in all of existence. Let me take you back, not to yesterday or last year, but to a time before there were stars, before there was light, about 13 billion years ago. Just a few 100,000 years after the Big Bang, the universe was a hot, dense fog. Ordinary matter, protons and electrons were jostling with photons of light in a thick, glowing soup. Nothing could settle. Nothing could clump together. The radiation pressure from all that light kept pushing matter apart, smoothing everything out. But dark matter didn't care about light. It didn't interact with photons at all. While ordinary matter was trapped in that luminous chaos, dark matter was already getting to work. You see, even in that smooth early universe, there were tiny, tiny variations in density. Quantum fluctuations from the very first moments, stretched across space by the rapid expansion we call inflation. In some places, dark matter was just a little bit denser, and where there's more density, there's more gravity, and where there's more gravity, more dark matter gets pulled in. Slowly, patiently, invisibly, dark matter began to clump. Think of it like fog settling in a valley. At first, everything looks uniform, a blanket of mist, but over time, gravity draws the fog down into the low places, the valleys and the hollows. The high ground begins to clear. The fog collects where gravity pulls it. Dark matter did the same thing, but on a cosmic scale. It gathered into dense regions, forming vast halos and filaments. And because it didn't interact with light or ordinary matter in any electromagnetic way, it could collapse faster, unimpeded. While ordinary matter was still trapped in the radiation-filled early universe, dark matter was already building the scaffolding. Then, about 380,000 years after the Big Bang, something beautiful happened. The universe cooled enough for electrons and protons to combine into neutral atoms. Light was finally set free. The cosmic microwave background, that ancient glow we talked about in the last chapter, began its journey across the cosmos, and ordinary matter, no longer held back by radiation pressure, could finally respond to gravity. It fell. Like rain soaking into the earth, ordinary matter fell into the gravitational wells that dark matter had already dug. It gathered along the invisible scaffolding, pooling in the densest regions, following the map that dark matter had drawn. Over millions and billions of years, that scaffolding grew into something extraordinary. Astronomers call it the cosmic web. Imagine the universe not as a random scatter of galaxies, but as a vast, intricate tapestry. Threads of dark matter stretch across hundreds of millions of light years, connecting node to node, cluster to cluster. These filaments are like highways of invisible mass, and along them, ordinary matter flows. Where 2 or 3 filaments intersect, you get massive galaxy clusters, the densest nodes in the web, containing hundreds or thousands of galaxies, bound together by the combined gravity of all that dark matter. Between the filaments, vast, empty voids, regions where almost nothing exists. No galaxies, no stars, just the quiet emptiness of space. The universe isn't a soup, it's a sponge, a foam, a web. And here's the astonishing part. We can see it. Not the dark matter itself, of course, but the galaxies that light up along its strands like pearls on a string. When astronomers map the positions of millions of galaxies across the sky, they see exactly this pattern. Filaments, clusters, and voids. Simulations run on the most powerful supercomputers, starting from those tiny quantum fluctuations and letting gravity do its work over billions of years, produce the same structure. The match between what we observe and what the models predict is almost spooky. It's as if the universe had a blueprint all along, written in darkness, waiting for the light to arrive and trace its outline. Let me tell you about one of the most beautiful aspects of this structure. Dark matter halos, the invisible envelopes surrounding each galaxy, follow a universal pattern. Astronomers discovered that no matter which galaxy they study, the density of dark matter decreases in a specific, predictable way as you move outward from the center. It's called the Navarro-Frank-White profile, named after the scientists who first described it. At the very heart of the halo, the dark matter is densest. As you move outward, it gradually thins, tapering off toward the edges. What makes this so remarkable is that this pattern is universal. It emerges naturally from the laws of gravity acting on collisionless dark matter. It doesn't matter if you're looking at a small dwarf galaxy or a massive elliptical giant. The dark matter halo follows the same mathematical curve. It's a kind of cosmic handwriting, a signature left by gravity itself. Think about that for a moment. The invisible scaffolding holding up every galaxy follows the same elegant rule. The universe, for all its diversity and chaos, has an underlying order written in darkness. Now, here's where the story becomes deeply poetic. Without dark matter, none of this structure would exist. If the universe contained only ordinary matter, the tiny fluctuations in the early cosmos wouldn't have had time to grow into galaxies. The expansion of space would have carried matter apart faster than gravity could pull it together. The radiation pressure would have smoothed everything out, but dark matter gave gravity a head start. It clumped first, creating the gravitational wells, the valleys where ordinary matter could gather. It built the framework, the skeleton, the invisible architecture. And then, when ordinary matter finally arrived, it had a place to rest. Stars formed in the densest regions. Galaxies coalesced along the filaments. Clusters assembled at the nodes. And all of it, every glowing thing you see when you look up at the night sky, is resting on a foundation you cannot see. The light needed the darkness. The stars needed the scaffolding. The visible needed the invisible. It's humbling, isn't it? To realize that everything we are, everything we see, everything that shines, exists only because of something that remains hidden. The cosmic web doesn't announce itself with light or color. It works quietly, patiently, holding everything together with nothing but gravity's gentle pull. Over billions of years, the web has grown more pronounced. Computer simulations show the evolution beautifully. In the early universe, shortly after the cosmic microwave background was released, the density variations were subtle, barely noticeable. But as time passed, gravity amplified them. The dense regions grew denser, the voids grew emptier. The filaments stretched and thinned, connecting ever larger structures. It's a process called hierarchical structure formation. Small things merge into larger things. Dwarf galaxies fall into larger galaxies. Galaxies gather into groups. Groups gather into clusters. Clusters align along filaments. And the whole thing keeps growing, evolving, becoming more intricate with every passing billion years. The cosmic web is not static. It's alive with motion, with accretion, with the slow dance of gravity pulling matter together, and the expansion of space gently stretching the distances between. And here we are, on a small planet orbiting an ordinary star, in a galaxy threaded through one of those filaments, held in place by a halo of dark matter we cannot see, part of a structure so vast it encompasses the entire observable universe. When you look up at the Milky Way on a clear dark night, you're seeing a slice of one filament. The band of stars arcing across the sky is our galaxy's disk, but surrounding it, invisible and immense, is the dark matter halo, and beyond that, stretching in all directions, are the filaments connecting us to Andromeda, to the Virgo cluster, to the great cosmic web itself. You are part of the web. We all are. every atom in your body was forged in stars that formed along these dark filaments. The oxygen you breathe, the calcium in your bones, the iron in your blood, all of it came from stars that were born because dark matter prepared a place for them. The universe gave the light a place to settle, and in doing so, it gave us a place to exist. So, as you drift towards sleep tonight, I want you to imagine the cosmic web stretching above you, invisible but undeniable. Threads of dark matter reaching across millions of light years, holding galaxies like dewdrops on a spider's silk, vast and patient and eternal. You are resting on that web, held by forces you cannot see, connected to structures beyond imagination. The darkness holds everything together, and without it, the light would have nowhere to rest. We've traveled together through the invisible universe. We've learned that dark matter holds galaxies in place, that it bends light around massive clusters, that it wove the cosmic web itself. We know it's there. The evidence surrounds us like the air we breathe. But here's the question that keeps scientists awake at night, the same question that might be drifting through your mind right now as you settle deeper into the quiet. What is it? What exactly is dark matter made of? What are the particles? What are their names? After all, we know what ordinary matter is. Protons, neutrons, electrons, atoms that bond together to make molecules, that gather into rocks and water and stars and you. We've seen them, measured them, understood them down to their quantum behavior. But dark matter remains a whisper, a gravitational fingerprint left at a cosmic crime scene. We know something was here, but we haven't caught it yet. And so, for decades, scientists have been listening for echoes in the dark, the sound of the universe, remembering what it's made of. Let me tell you about the search. It's one of the most patient, most hopeful endeavors in all of science, because to find something that doesn't interact with light, you have to get very, very quiet, and you have to wait. The first candidate, the one that's captured the most attention, has a wonderfully paradoxical name, WIMPs, weakly interacting massive particles. Imagine a particle that has mass, enough to account for all that gravity we've detected, but that barely interacts with ordinary matter at all. It doesn't bounce off atoms like a billiard ball. It doesn't emit light or absorb it. It simply drifts through, ghost-like, almost never touching anything. Almost never. But not quite. The theory suggests that every once in a great while, maybe once in a billion collisions, a WIMP might actually bump into the nucleus of an ordinary atom. Just a tiny nudge, a gentle knock that would set the nucleus recoiling ever so slightly. That's what scientists are waiting for. That single, defining moment, that one knock in the dark. To hear it, they've built some of the quietest places on Earth. Deep underground, sometimes nearly a mile beneath the surface, beneath layers of rock that filter out cosmic rays and background radiation, scientists have constructed chambers of pure silence. These aren't just dark rooms. They're laboratories designed to eliminate every possible source of noise, except the one signal they're searching for. One such experiment is called Lux Zeppelin, or LZ for short. It sits nearly a mile underground in South Dakota, in an old gold mine that's been transformed into a cathedral of scientific patience. At the heart of LZ is a tank containing 10 tons of liquid xenon. Xenon is a heavy, noble gas, transparent when liquefied, and extraordinarily pure. The scientists spent years purifying it, removing every trace of radioactive contamination, because even a single stray particle could create a false signal. The xenon sits in the dark, waiting. Monitoring it are thousands of sensitive detectors, watching for the faintest flash of light or tiny pulse of energy that would indicate a WIMP has collided with a xenon nucleus. Think of it like trying to hear a pin drop in a thunderstorm, except the scientists have built a room where the thunder can't reach. They've silenced the cosmic rays, filtered out the radiation from the rocks, eliminated interference from every possible source. And then they wait. Days, months, years, over 1,000 days of continuous observation, watching for that single unmistakable event. So far, the knock hasn't come. Not definitively. Not in a way that can't be explained by other, more ordinary processes. But here's the beautiful part. Even not finding something tells us something. Every day the detectors run without a signal. They narrow down the possibilities. They rule out certain masses, certain interaction strengths. They're carving away at the space where WIMPs could hide, like sculptors chiseling away marble to reveal what's underneath. The search isn't a failure, it's a refinement, a patient process of elimination that brings us closer to the truth, one silent day at a time. But WIMPs aren't the only candidate. The universe might have other whispers to share. At the opposite end of the spectrum, there's something called the axion. If WIMPs are the heavy, strong whispers of dark matter, axions are the faintest breath imaginable. Axions are hypothetical particles so light, so low in energy, that they're almost like waves rather than particles. They were originally proposed to solve a completely different problem in particle physics, something called the strong CP problem. But physicists realized that if axions exist, they could be dark matter too. Searching for axions requires a different kind of patience. Instead of waiting for a collision, scientists look for axions converting into photons, particles of light, inside powerful magnetic fields. It's like trying to coax a ghost into revealing itself by setting up the perfect conditions and seeing if anything appears. These experiments, with names like ADMX, use cavities filled with electromagnetic fields, tuned to precise frequencies, waiting for the faint signal of axions transforming into detectable light. It's an incredibly delicate process, like trying to hear a single note sung by a choir of silence. And then there's a third possibility, one that's perhaps the most poetic of all. What if dark matter isn't tiny particles at all? What if it's ancient, massive objects formed in the very first moments after the Big Bang? They're called primordial black holes, not the giant black holes that form when massive stars collapse, but tiny ones, ranging from the mass of an asteroid to perhaps a small planet, formed in the intense conditions of the early universe. These would be invisible, not because they're made of exotic particles, but because they're black holes. They don't emit light. They only reveal themselves through their gravitational pull. Scientists search for them by watching how light from distant stars bends and brightens when one of these dark objects passes in front of it, a technique called gravitational microlensing. It's like watching for a shadow to cross the sun, except the shadow is invisible and the sun is a star halfway across the galaxy. 3 possibilities, 3 different searches. WIMPs, the heavy and elusive; axions, the light and ethereal; primordial black holes, the ancient and quiet. And here's what makes the search so remarkable. scientists are conducting all three simultaneously. They're listening for the heavy knock, the faint breath, and the gravitational shadow all at once, because they don't know which one is right. Maybe none of them are. Maybe dark matter is something else entirely, something we haven't even thought of yet. But that's the nature of exploration. You don't always know what you're looking for until you find it. What keeps the scientists going year after year, experiment after experiment, is the knowledge that dark matter is out there. It's real. The evidence is overwhelming. Somewhere in that vast parameter space of possible particles and masses and interactions, dark matter is waiting to be found. And when it is found, when that signal finally comes through, clear and unmistakable, it will be one of the greatest discoveries in the history of science. It will answer a question that's been haunting us since we first realized the universe was mostly invisible. Until then, the search continues. In underground laboratories shielded from cosmic noise, in magnetic cavities tuned to impossible precision, in telescopes watching for the faintest gravitational flicker, they are listening for echoes in the dark, the sound of the universe remembering what it's made of. And you know what? You can think of yourself as part of that search too. Because right now, as you lie there, trillions of dark matter particles are streaming through you, through your skin, your bones, your heart. They pass through the earth itself without slowing down, without leaving a trace. You are immersed in the very mystery we're trying to solve. You're swimming in dark matter every moment of your life, feeling nothing, untouched by its presence, yet fundamentally shaped by the universe it helped build. In a way, we're all waiting for that knock, that moment when the invisible finally announces itself, when the universe's greatest secret finally speaks its name. So as you drift toward sleep tonight, think about those patient scientists in their underground chambers. Think about the xenons sitting in the dark, waiting for a whisper. Think about the detectors scanning the sky for the faint shadow of an ancient black hole. They're listening on our behalf, waiting for the echo that will change everything. And maybe, just maybe, in the quiet of your own thoughts, you can hear it too. Not the particle itself, but the profound mystery it represents. The understanding that the universe is stranger and more beautiful than we ever imagined. The darkness is not empty. It's full of possibility, full of particles we haven't named yet, forces we haven't understood, secrets waiting patiently to be discovered. And all it takes is listening. Patient, quiet, hopeful listening. We've journeyed across cosmic distances together. We've watched dark matter weave galaxies, bend light, and shape the largest structures in existence. We've listened to scientists search for its whisper in underground chambers nearly a mile beneath the surface of the Earth. But now, let's bring the journey home, all the way home, to right here where you are, lying quietly in the dark. Because here's something extraordinary. Dark matter isn't just out there, billions of light years away in distant galaxy clusters. It's here, right here, in this room, passing through you, through me, through the Earth itself. And yet, somehow, we're completely safe. Let me show you the most beautiful paradox in all of cosmology. Remember how we learned that dark matter makes up 85% of all the mass in the universe? That it holds galaxies together with invisible halos 5 to 10 times heavier than all the visible stars combined. You'd think that with so much dark matter out there, our own little corner of space would be swimming in it, that the solar system would be thick with dark matter, influencing the orbits of planets, tugging on the moon, shaping our daily lives. But it doesn't work that way. Here's why. The solar system sits within the Milky Way's dark matter halo. Yes, we're embedded in it, like a marble suspended in a vast sphere of invisible mass. But that halo is enormous. It extends hundreds of thousands of light years in every direction, and its mass is spread smoothly throughout that volume. At our location, about halfway out from the galactic center, the dark matter is there, but it's so thinly distributed that its local density is surprisingly low. Scientists have calculated how much dark matter is contained within the orbit of Neptune, the farthest major planet in our solar system. All that volume, billions of cubic kilometers, stretching from the Sun to the outer edge of the planetary system, contains about 10 to the 17th kilograms of dark matter. That sounds like a lot, and it is, in absolute terms. But let me give you perspective. 10 to the 17th kilograms is roughly the mass of a large asteroid, something maybe 100 kilometers across, a cosmic pebble. The Sun alone weighs 2 million trillion kilograms. Jupiter weighs 300 times more than all the other planets combined. Even tiny Pluto has more gravitational influence on our neighborhood than all the dark matter within Neptune's orbit. That's the first part of the paradox. The scaffolding that holds galaxies together is, locally, barely noticeable. The force that shaped the cosmic web doesn't even register on planetary scales. It's like living in a vast forest and realizing that while the forest itself is held together by its root system spreading beneath the soil, the roots beneath your single footstep are so thin they don't affect your balance at all. The dark matter is there, but it's gentle, diffuse, spread so smoothly that it doesn't clump or pull in ways that disturb the delicate dance of planets around their star. Our solar system was shaped by the gravity of the Sun and the push and pull of the planets themselves. The dark matter halo provided the larger context, the galactic environment in which the Sun and its family could form. But once formed, the planets orbit according to the Sun's gravity, untroubled by the invisible halo surrounding them. And here's the second part of the paradox, the part that's even more astonishing. Even though the total mass is small, the number of dark matter particles passing through you every second is staggering. Scientists estimate that millions, perhaps trillions of dark matter particles flow through your body every single second, through your skin, your muscles, your bones, through the floor beneath you, the walls around you, the planet below. They're streaming right now. As you read these words, as you breathe, as your heart beats quietly in your chest, and you feel nothing, because dark matter doesn't collide, it doesn't interact electromagnetically, it doesn't push atoms aside or heat them up, it simply passes through like a ghost walking through a wall, like light shining through clear glass. You are constantly immersed in a river of dark matter, and yet you remain completely untouched. Over the course of your entire lifetime, about 1 milligram of dark matter will have passed through your body. 1 milligram. The weight of a single grain of sand. Isn't that extraordinary? The universe's most dominant form of mass flows through you in unimaginable numbers, and yet, across 100 years of life, only the weight of a grain of sand would accumulate if you could somehow capture every single particle. That's how gentle dark matter is. That's how weak its interaction with ordinary matter truly is. It's the ultimate paradox of proximity. We're surrounded by the infinite, yet untouched by it. We live in the halo of the invisible, safe, small, barely brushed by its hand. And there's something deeply comforting about that, isn't there? The same force that holds galaxies together, that weaves the cosmic web, that built the scaffolding for everything we see, is content to leave us alone. It doesn't demand our attention. It doesn't interfere with the chemistry of life, the warmth of the sun, the gentle pull of the moon. It simply exists, everywhere, all the time, doing its cosmic work on scales so vast that we barely register its presence here at home. Think about that as you lie there. Dark matter is flowing through you right now. 1 trillion invisible particles, perhaps more, slipping through the spaces between your atoms, through the nucleus of every cell, through the very fabric of your being, and yet you are safe, you are whole, you are undisturbed, because dark matter holds, but it does not squeeze, it shapes, but it does not intrude. It surrounds, but it does not suffocate. It is the universe's way of being present without being overwhelming, of having influence without demanding recognition. We live in a cosmos where the majority is invisible, where the scaffolding remains hidden, where the most important structures work in silence, and here we are, small and luminous, held gently in the halo of something we can barely detect, let alone understand. It's humbling and beautiful. So tonight, as you settle deeper into rest, I want you to imagine the dark matter flowing through you, not as something to fear, but as something to marvel at, a cosmic river, ancient and invisible, carrying the memory of the early universe, the weight of galaxies, the silence of the void. It asks nothing of you. It touches you so lightly you'll never notice. And yet, without it, none of this, the stars, the planets, the quiet night you, would exist. We live in the halo of the invisible, safe, small, barely brushed by its hand, and that is enough. And so we've arrived at the end of our journey. Together, we've drifted through the invisible universe. We've learned its secrets, felt its presence, understood its silence. We began with a question: what if most of the universe is invisible? And now we know it is. 95% of everything that exists, all the mass and energy that fills the cosmos, is something we cannot see. Dark matter, dark energy, forces and particles that reveal themselves only through their effects, never through their light. It's a humbling realization, isn't it? That the stars, for all their brilliance, are merely decorations, that the galaxies, for all their grandeur, are held together by something we cannot name, that the cosmic web, the largest structure in existence, is woven from threads we cannot see. But here's what I want you to take with you as you drift towards sleep tonight. The universe is not defined by what shines, it's defined by what holds. Dark matter doesn't need to announce itself. It doesn't need to glow or shimmer or demand attention. It simply does its work, quietly, patiently, everywhere at once, holding galaxies together, shaping the cosmic web, allowing the stars to rest upon its invisible scaffolding. And in that there's something deeply beautiful, because the most important things are often invisible. Think about it. Love doesn't shine, thought doesn't glow, memory leaves no trace in the light. Gravity itself, the force that keeps your feet on the ground and the earth around the sun, is completely invisible. We've always known that the invisible matters. Dark matter, just reminds us that this truth extends to the largest scales imaginable. The universe is engaged in a profound struggle right now, a tug-of-war between dark matter and dark energy. Dark matter pulls everything together, trying to hold the cosmos in its gravitational embrace. Dark energy pushes everything apart, accelerating the expansion, stretching space itself. Which force will win? We don't know yet. The answer will determine the fate of everything. Will the universe expand forever, growing colder and darker until the last stars burn out and even black holes evaporate into the void? Or will dark matter eventually slow the expansion, perhaps even reverse it, bringing everything back together in a final collapse? The universe is asking itself these questions right now, and we are here, tiny and luminous, watching it unfold. But tonight, in this moment, none of that urgency touches you. You are safe. You are held. You are part of something vast and ancient and profoundly mysterious. Right now, dark matter is streaming through you. Trillions of particles, invisible and silent, passing through your body without leaving a mark. You are immersed in the cosmic river, surrounded by the very mystery that holds galaxies together. And yet, you feel nothing, because dark matter is gentle. It doesn't demand your attention, it doesn't disturb your rest. It simply exists everywhere, all the time, doing its cosmic work while you dream. So as you close your eyes tonight, think about the weight of the invisible. Think about the dark matter, halos wrapping around galaxies like gentle hands. Think about the cosmic web stretching across billions of light years. Threads of darkness connecting everything that shines. Think about the scientists in their underground chambers listening patiently for the whisper of a particle that might never come. They're searching for the same thing we all are: understanding, connection, the knowledge that we are part of something larger than ourselves. And we are. We are part of a universe where darkness holds the stars. I close my eyes and feel the weight of the invisible. The stars drift above, held in their ancient orbits. The dark matter flows through me, silent and eternal. And in between, in the space where light and darkness meet, I dream. The universe is mostly mystery, and that's okay, because mystery is not the absence of knowledge. It's the presence of wonder. So rest now. Let the darkness hold you. Let the invisible scaffolding of the cosmos carry you gently into sleep. You are safe. You are small. You are barely brushed by the hand of the infinite. And that is exactly where you belong. Good night, dreamer. May the darkness hold you gently.